Okay, so in the previous class, we were discussing about the different types of matrices and the different operations that we can do on matrices. Now, there is one small operation which I didn't mention or I forgot to mention, but this is a very trivial operation. So, there is a fourth operation which I forgot to mention, that is a scalar multiplication. So those who are taking fair notes, they can just include this. There is a fourth operation which is a scalar multiplication. Now, what is actually a scalar multiplication? So this is nothing new, but let me just find some space to do this. Um, yep, I have space here. So this is pretty much a rough page. So let me take any matrix. So for example, let me take the very matrix which I have taken here. So this is 2, 1, 3, 4, 0, minus 2. So this is the matrix which I have taken previously and I am taking this. So by scalar multiplication, it means that multiplying this matrix, this whole matrix, with some scalar number. Scalar means any number. So if I want to write 5a, 5a means I am multiplying this matrix with 5. Then what happens? This 5 gets multiplied to the whole matrix. So therefore, this will become 10, 5, 15, 20, 0, and minus 10. So this is my scalar multiplication. So instead of 5, if I have any other number, so that will get multiplied with all the elements of the matrix. So this is scalar multiplication which I missed out. So now in today's class, let me do something. Let me address certain problems. Now these are the problems which were given yesterday. So let me just take these problems, some of the typical problems which you may find difficulty in solving, and let me just solve all these three problems for you. So let me start. Let me take a fresh page. Yes. So let me start with the first problem. This is question number 3 subpart 2. So this is 3 subpart 2 from exercise 3.2. The problem is given. I am given this matrix 1, 2, 3. It's a column matrix, and another matrix 2, 3, 4, and I am asked to multiply these two matrices. So when I am going to multiply these two matrices, so you can see, let me just, yep. So let me just first make you understand how this multiplication will happen. Now this is a column matrix, so there are 3 rows and 1 column. So this is 3 by 1 matrix, right? And this is only 1 row, there are 3 columns, so this is 1 by 3 matrix. Now first let me check if the multiplication is possible or not. Yes, obviously possible, because this one and this one, they match, so the multiplication is possible. And now we need to understand what will be the dimension of the product matrix. So the product matrix is actually going to be 3 by 3. So it is going to give me a 3 by 3 matrix. So you have to first understand what the product matrix is going to be. So this product matrix is going to be a 3 by 3 matrix. So now we need to understand how we must get this 3 by 3 matrix. So in 3 by 3 matrix, you can understand there will be a first row, first column, first row, second, first row, third, second row, first, second row, second, second row, third, third row, first, third, second, third, third. So now in that case, I have to do what? As we know, the multiplication goes, the rows of the first matrix will get multiplied with the columns of the second matrix. So here, first we need to understand what are the rows. So here these are the rows and these are the columns. So here in this matrix, each and every single row has got only one element. These are the elements each and every single row has got. And similarly, these columns of the second matrix, they have only one element. So in the first row, first element, 1 will get multiplied with 2. So that is 2. That's it. Then 1 will get multiplied with 3. So that is 3. 1 will get multiplied with 4. That is 4. Then this 2 gets multiplied with 2. So this is 4. 2 gets multiplied with 3. That is 6. 2 gets multiplied with 4. That is 8. Then 3 getting multiplied with 2, that is 6. 3 getting multiplied with 3, that is 9. And this is 12. So this is your matrix. So just always remember, in the first matrix, all the rows get multiplied with the second matrix, all the columns. So if the row has got only one element here, and here the column has got only one element, so you just multiply the row with the column, as there is no other extra elements, so there is no question of adding them. So you just write whatever the product is. But instead, if there would have been another element in the row, and here also if there would have been another element in the column, so individually you multiply and then add, and then you write whatever is the final sum is for every single position, right? So now let me deal with the next problem. Now next problem is not that hard though, but still, the way the question is given, it may make you feel a little bit confused. So this is cos x minus sin x, 0, sin x, cos x, 0, 0, 0, 1. So now I am supposed to show that, if it is visible, yes, I am supposed to show that fx into fy is f of x plus y. So first let me write what is f of y. So f of y is cos y minus sin y, 0, sin y, cos y, 0, 0, 0, 1. So now I need to multiply fx into fy. So that means I need to multiply these two matrices. So just once again write them side by side. So this is cos x minus sin x, 0, sin x, cos x, 0, 0, 0, 1. Once again, cos y minus sin y, 0, sin y, cos y, 0, 0, 0, 1. So this is the product. Now let me do the product. Now this is going to be a big product. So cos x into cos y, cos x into cos y. Now minus sin x into sin y. So this is minus sin x into sin y, and 0 into 0. So nothing, so this doesn't contribute. Again, this into this. So cos x into minus sin y. So that is minus cos x sin y. Then minus sin x into cos y. So that is minus sin x cos y. And again 0 into 0 is 0. Then this into the third one. So cos x into 0 is 0, minus sin x into 0 is 0, 0 into 1 is 0. So the third element is 0. Then now the second row, sin x into cos y. So this is sin x into cos y. Then cos x into sin y plus cos x into sin y, and 0 into 0. So once again it doesn't contribute. Then sin x into minus sin y. So this is minus sin x sin y, cos x into cos y. So plus cos x into cos y, then 0 into 0. Done. And then finally this into this, so sin x into 0 is 0, cos x into 0 is 0, 0 into 1 is 0. Done. Let me put the bracket. Okay, now the last one, 0 0 1 into this, so 0 into cos y is 0, 0 into sin y is 0, 1 into 0 is 0, 0 into minus sin y is 0, 0 into cos y is 0, 1 into 0 is 0, 0 into 0 is 0, 0 into 0 is again 0, and 1 into 1 is 1. So now let me just let me take another page. So from here, what do I get? So I can see cos x cos y minus sin x sin y. So this is actually nothing but cos of x plus y, if I am not wrong. So cos x cos y minus sin x sin y gives me cos of x plus y. Then again, if I take the minus common, then I am left with cos x sin y plus sin x cos y. So this is actually sin of x plus y with the minus common. Then this is 0. Then sin x cos y plus cos x sin y is again sin of x plus y. And this cos x cos y minus sin x sin y. So this is cos of x plus y. This is 0 and this is 0, 0, 1. So now we can see, given the structure of the function fx is wherever x is, the x is here. Wherever y is, the y is here. So now this is x plus y everywhere. So can I write this as capital F of x plus y given the structure of the function? So that proves, so therefore it proves that fx into f of y, that is equals to capital F of x plus y. Fine. So this is one problem solved. Then number 18. Now number 18 is a very simple problem, but it requires a little bit of work. Now 0 minus tan of alpha by 2, tan of alpha by 2, 0. And I know what is I. I is a second order identity matrix, so this is I. And I need to prove I plus A is equals to I minus A into cos alpha minus sin alpha cos alpha. So here let me first write what is I plus A and I minus A. So I plus A is just add these two. So it becomes 1 minus tan alpha by 2, tan alpha by 2 and 1. So this is I plus A. And I minus A, this is this minus this. So 1 minus 0 is 1. 0 minus of this, so minus of minus, that becomes plus tan alpha by 2. 0 minus this, so this is negative tan alpha by 2. And 1 minus 0, this is 1. So these are the two matrices first we need to know. So now let me start off with RHS. So RHS is what? I minus A into cos alpha minus sin alpha cos alpha. So what is I minus A? I minus A is 1 tan alpha by 2 minus tan alpha by 2, 1, multiplied by cos alpha minus sin alpha cos alpha. Fine. I hope till this much it is clear. Now if you don't understand, then the only good thing is that you can always rewatch the video right from the beginning, from where the problem has started, so you can just go through the steps and understand. Now I need to multiply these two. So in this case, this row multiplied with this column. So 1 into cos alpha is cos alpha, and tan alpha by 2 into this. So tan alpha by 2 into sin alpha. Fine. Then this multiplied with this. So minus sin alpha plus tan alpha by 2 into cos alpha. Fine. Then again, this multiplied with this. So this is minus tan alpha by 2 cos alpha plus sin alpha, and minus tan alpha by 2 into this. So this is sin alpha into tan alpha by 2 plus cos alpha. Fine. Just check the product. Do it once all by yourself, then you will be able to understand how the product is coming. Now the work of matrix is done. So now no more work of matrix is left for us to do. The only thing that is left for us to do is now to solve each and every single element. Now there is something trigonometric forms are there, so I need to solve the trigonometric form. And let me just remind you once again, if you have neglected trigonometry in class 11, then class 12 is going to be very dreadful for you, because trigonometry is in every single step throughout your syllabus, because trigonometry is so intrinsic that you will be requiring trigonometry in almost all the topics that you are going to cover. So in that case, do brush up the formulas of trigonometry and ensure that you need not think of the formula while you are trying to solve a problem, because now you can understand one very important thing from the previous problem itself, that this formula cos of x plus y, this should be intrinsic to you right now, that you should remember what the formula for cos of x plus y and sin of x plus y and all these formulas, because if you don't remember the formulas, then definitely this problem will be completely gone wrong, just because that you don't remember the trigonometry. Because the matrix part is easy, so doing the multiplication, doing the addition and all those things are easy, but remembering the trigonometry formula, that is very important, so you have to remember them. So if you have neglected, please ensure you go through. So take that as a task, ensure you do it, and then you go on trying to solve all the problems involving trigonometry. Okay, so now let me just come back. Now here, what do I need to do? See this tan alpha by 2. Everywhere there is one tan alpha by 2. So now this tan alpha by 2, I can write this as sin alpha by 2 by cos alpha by 2. So let me write that. So cos alpha plus this tan alpha by 2 becomes sin alpha by 2 by cos alpha by 2. And this sin alpha remains sin alpha. Fine. Here also minus sin alpha plus sin alpha by 2 by cos alpha by 2 into cos alpha. Please ensure you write them separately so that you don't mix them up and make this whole thing a mess. So therefore this minus tan alpha by 2 becomes minus sin alpha by 2 by cos alpha by 2 into cos alpha plus sin alpha, and again here sin alpha into sin alpha by 2 by cos alpha by 2 plus cos alpha. So this is a very important and like the tricky step of this whole problem. So now once this step is clear, the next thing that we are going to do, so let me just keep this here. So let me just keep this here. And now let us move to the next step. So in the next step, let me take the LCM. So if I take the LCM, what happens? Cos alpha by 2. See, cos alpha by 2 is in the denominator. So here also it is in the denominator. Here also it is in the denominator. Here also it is in the denominator. So now it is cos alpha into this cos alpha by 2 gets multiplied. So this is cos alpha by 2 plus sin alpha into sin alpha by 2 whole divided by cos alpha by 2. This is the first term. Next, in the second term, this cos alpha by 2 comes up. So this is minus sin alpha into cos alpha by 2 plus sin alpha by 2 cos alpha whole divided by cos of alpha by 2. Next, this cos alpha by 2 gets multiplied here. So this is minus sin alpha by 2 cos alpha plus sin alpha cos alpha by 2 by cos alpha by 2. And here sin alpha into sin alpha by 2 plus cos alpha into cos alpha by 2 whole divided by cos of alpha by 2. Fine. So this much it is clear. Now just see what is happening. So sin A cos B plus sin A sin B. So this is a formula for cos of A minus B. So therefore I can write this cos this alpha minus alpha by 2. Just check if I can write cos A cos B plus sin A sin B. So that becomes cos of A minus B. And I have cos of alpha by 2 in the denominator. Done. Next, sin A sin B, sin A cos B minus cos A sin B. So this is sin of A minus B formula. But here I have to understand which one is A and which one is B. So this is sin A, this is my A, cos B. So this is cos A, this is sin B. Just think of this, which one is A and which one is B. In that case you won't be mistaken or you won't be confused. So sin A cos B minus cos A sin B. So this is sin of A minus B. So sin A minus B. So A is alpha by 2. So that is alpha by 2 minus alpha by cos of alpha by 2. Then again here also sin A cos B cos A sin B. So therefore that is sin of alpha minus alpha by 2. The same thing, it's just two opposite things. Just ensure you don't confuse. Cos of alpha by 2. And this is again the same thing, cos alpha by 2 plus sin alpha sin cos A cos B plus sin A sin B. So this is cos of alpha minus alpha by 2 by cos alpha by 2. Done. So now this gives you cos of alpha by 2 by cos of alpha by 2. This is minus sin alpha by 2 by cos of alpha by 2. This is again sin alpha by 2 by cos alpha by 2. And this is again cos alpha by 2 by cos alpha by 2. So finally, what do I get? I get this is as 1, this is minus tan alpha by 2, this is tan alpha by 2, and this is 1. So see from where we have started. We started from the RHS. We went on solving and we came to this. But what is this? This is nothing but this I plus A. This is nothing but my I plus A. So now I can write this as I plus A. See, I can write this. This is my I plus A. Let me just zoom out a little bit. Ah, right. So this gives me LHS. Fine. So this is my proof. So now I hope you won't be having any doubt with this. So once you have gone through the whole thing, then I am pretty sure you will be able to understand what the whole problem is like. Just the calculation, it is nothing. The multiplication is done here itself, and rest, the whole problem is pretty much calculation of trigonometry. So you have to ensure that your trigonometry is in good shape so that you are able to solve the problem. Okay, so now this completes the first part in the sense the basic part, that is the types of matrices, the operations and everything. Now let me move to today's topic. Today's topic means the topic which I need to discuss, that is the next part. It is transpose. Transpose of a matrix. Now, transpose of a matrix, this is something, those who are computer student, once again, you already know, you have the idea, but you definitely haven't done the problems yet. Now, let me just brush it up. So, if A is a matrix given whose order is m by n, so there are m rows and n columns in the matrix. Now, I am taking any general matrix for the matter of fact. Then, transpose of A is denoted by A with a T on the top or A with a dash. So you can use any of the two notations, whichever you feel like, or which in the book, whichever way it is given. So A raised to the power T, or I should not say raised to the power T, or A with a T on the top, and A prime or A dash. This is the notation for transpose. Now, what is A transpose? A transpose is basically, okay, so if this is actually Aij in cross L. What is Aij? This is the structure of the element. This is how the element in the matrix looks. Then A dash is nothing but Aj n cross M. That means, what it actually means? It means that all the elements in the row will become the elements in the column, and all the elements in the column will become elements in the row. And also the order of the matrix, whatever is the order of the matrix, the transpose matrix will have just the reverse order, just the opposite order. All the rows become columns and all the columns become rows. So for example, let me take an example. So let me take those examples which I have already taken, which we already have seen. For example, yeah, so this same example I am taking just to ensure that there is a parity with all the things that we do. So if this is the matrix that I have taken, so in this matrix its transpose will be nothing. So you understand, the rows becomes column. So it is written horizontally, now I will be writing vertically. So this is 2 1 3 4 0 minus 2. So this is my transpose. So now you see this was actually a 2 cross 3 matrix, 2 rows and 3 columns, but now it has changed into a 3 cross 2 matrix. Why? Because obviously the rows and columns, they have interchanged. Now, properties of transpose. So this is important. Properties of transpose. So the first property that we have, it is an obvious property that A transpose whole transpose is A itself. So if you take transpose of transpose, then you get back the matrix itself. Then number two, if you multiply the matrix with some constant k, that is a scalar multiplication, and if you take the transpose of this, then it is k times A transpose. So scalar multiplication and then taking transpose is same as first taking transpose and then taking the scalar multiplication. Number three is A plus minus B whole transpose, that is equals to A transpose plus minus B transpose. So adding the matrix and then taking transpose, or subtracting the matrices then taking transpose, is same as first taking the transpose and then subtracting or adding. So this is third one. And the fourth one, this fourth one is very important, and it is just the tricky one. The transpose of the product. So if you are taking product of the two matrices and then you are taking the transpose, it is equals to the reverse actually. Reverse means taking the transpose of the matrices and then multiplying in the reverse order. So this is very important. This is a very important property. So these are the four properties we have, and obviously we are going to solve the problems on this in few moments. I told you as I have to solve the problems because these things are a little bit new. And then there is another thing, symmetric and skew symmetric matrices. Okay, now when I am discussing about symmetric and skew symmetric matrices, the first and foremost thing that we need to understand is that this property of symmetric and skew symmetric is only possible for square matrices only. So now all these properties are general properties. These properties are true for all kinds of matrices. Doesn't matter if it is square, rectangular, column, row, whatever it is. All these properties are valid for any kind of matrices. But symmetric and skew symmetric matrices, this is possible only when a matrix is a square matrix. So let me just write only for square matrices. If a matrix is not square, then I can't think of being a matrix being symmetric or skew symmetric. So now let me take a matrix A, which is obviously a square matrix. So it is of the order n. So just any general matrix. Then it is said to be symmetric. A matrix is called symmetric if the transpose is exactly equals to the matrix. If you take the transpose of a matrix and after taking the transpose, if you get back the same matrix, then that matrix is called a symmetric matrix. And number two, skew symmetric. Now it is already obvious, if I call this as symmetric, then what can be skew symmetric? Then skew symmetric is the transpose is exactly negative of the matrix. So if the matrix turns out to be, if the transpose turns out to be negative of the given matrix, then I call that matrix as a skew symmetric matrix. So let me take an example and let's see what these are. So for example, say your identity matrix itself. Let me take this as an example: 1 0 0 0 1 0 0 0 1. So let me take the transpose of this, so I dash. So if I take the transpose of this, what I am supposed to do, I am supposed to write the rows into columns and columns into rows. So this is 1 0 0, so 1 0 0, 0 1 0, and this is 0 0 1. So you see I get back the same matrix. I don't have any change. So therefore this is a case of being symmetric. Fine. Now I can take any other example and I can do it. For the matter of fact, say A, I am taking a 2 by 2 matrix. So this is 2 4 4 3. So let me take this. So if I take this and I take the transpose of this, so what is happening? See, 2 4 I will be writing as 2 4, and this 4 3 I will be writing as 4 3. So I get back the same matrix, no change. So this is also an example of symmetric matrix. Now let me take an example of skew symmetric matrix. So let me take B. I have to just construct an example. So 0 1 2, then minus 1 0 3, then minus 2 minus 3 0. So let me just take this as an example. So if I have taken this example, see, if I am taking B transpose, so what is happening? Rows becomes column. So this is 0 1 2, minus 1 0 3, minus 2 minus 3 0. So I can see what did I actually get. See, all these positions 1 2 3, they became minus 1 minus 2 minus 3, and this minus 1 minus 2 minus 3 became 1 2 3. So actually I got the negative of the matrix back, isn't it? So this suggests that it is a skew symmetric matrix. This is a skew symmetric matrix. Now, when taking transpose of a matrix, just check this one important thing. All the elements in a row and column, they gets interchanged, but except the diagonal elements. See, the diagonal elements remain at its place, so they don't change. You will see all the elements will get here and there, but the diagonal elements remain at its place. It doesn't change. Here also, these zeros, they remain at this place only. The zeros, they are not going to change at all. So therefore, in case of a skew symmetric matrix, just in order to be a skew symmetric matrix, the transpose of the matrix is supposed to become the negative of the given matrix, isn't it? That is the definition of skew symmetry. But if these elements are not supposed to change, so that means what? If I have any other number here, say like instead of 0, if I would have had 1, then in the transpose this 1 should have become minus 1 according to the definition of what skew symmetric is. But if this position element doesn't change in the transpose, because I already told you the diagonal elements does not change, then this, if this would have been 1, then this one can't become minus 1, if the logic is clear to you. Once again, what I meant is the diagonal elements in the matrix do not change when you are taking transpose. They remain at its place, right? Now, if a matrix is supposed to become skew symmetric, by the definition of skew symmetric, it means that the element in its position, doesn't matter what happens in the transpose, it is going to become the negative of that element. You see, this one ends up becoming -1, this 2 ends up becoming -2, this 3 ends up becoming -3, so same here also. So now this element must become minus of this element should end up become minus of this element, this element should end up become minus of this element. But the diagonal elements do not change. So the only possibility is that the diagonal element, they must be 0. Why? Because 0 is only negative of itself. There is no other element or no other number which is negative of itself. So therefore, a very important criteria, this is a criteria that for a matrix, let me just mention a square matrix to become skew symmetric, the diagonal elements must be 0, which is important. If the diagonal elements are not 0, then you can just confidently say that that matrix can never be skew symmetric. It can become symmetric or not, that is a different issue, but at least you can be assured of the fact that that is definitely not a skew symmetric matrix. Okay, now if this part is clear, then we move to the next thing, that is called representation of a matrix as sum of symmetric and skew symmetric matrices. Just first wrap your head around the idea. What it is suggesting that I am given a matrix, any matrix. Now it is definitely not told what kind of matrix it is. So obviously square matrix, but it need not be a symmetric or skew symmetric. It can be any matrix, any square matrix. Now I need to represent it as a sum of a symmetric and skew symmetric matrix. Means if capital A is a given matrix, I don't know, it is obviously a square matrix, but it is not necessary that this has to be a symmetric or skew symmetric. Now I need to represent this as a sum of two matrices. One is P, another one is Q, where P has to be symmetric or vice versa, whatever it can be, symmetric, and this Q has to be skew symmetric. So that is the idea. Now this is possible for any square matrix. You can always write any square matrix as sum of a symmetric matrix and a skew symmetric matrix. So let me see how. Now let me take an example, any arbitrary example. So this is 1 2 3 4, for just to ensure that this is definitely not a symmetric matrix or a skew symmetric matrix. We can see very well because its transpose is not equal to this, or definitely the diagonal elements are not 0, so they are not skew symmetric for sure. Now let me take let me take its transpose. So if I take the transpose of this matrix, what do I get? 1 2 3 4. Fine, I get this. I think no trouble understanding this, that I have got this. Now see this, if I do A plus A transpose, if I do A plus A transpose, what do I get? 1 plus 1 is 2, 2 plus 3 is 5, 3 plus 2 is 5, and 4 plus 4 is 8. So now name this. Okay, let's not name it first. See what this matrix I have got. This matrix 2, 5, 5, 8, isn't this a symmetric matrix? See, if I take A plus A transpose whole transpose, I am getting back 2, 5, 5, 8 actually. See, 2, 5, 5, 8. I am getting back. So therefore, this A plus A transpose is a symmetric matrix. It is a symmetric matrix always. So it doesn't matter what A is. A doesn't matter what A matrix is given. A plus A transpose is always a symmetric matrix. Always. Fine. Now, once again, let me do A minus A transpose. If I am doing A minus A transpose, what do I get? 1 minus 1, that is 0. 2 minus 3, that is minus 1. 3 minus 2, that is 1. And 4 minus 4 is 0. Right? So that means, now once again see, if I take A minus A transpose whole transpose, that gives me 0 minus 1, 1, 0. This is exactly negative of this. This one is negative of this one. So therefore I can say A plus A, minus A dash is actually a skew symmetric matrix. Okay, this is a skew symmetric matrix. So now what happens? See, can I write this A? Now once I have understood the fact that A plus A transpose is symmetric, doesn't matter what, and A minus A transpose is skew symmetric, doesn't matter what, then can I write this A as half of 2A? Just check, I can always write this. Now this half of 2A can be written as A plus A. Half of 2A can be written as A plus A for sure. Then half of 2A can be written as A plus A transpose minus A transpose plus A. I mean, I have just added A transpose and I have subtracted A transpose. So this is half of A plus A transpose plus half of A minus A transpose. See, I can write this or not. So this is just a derivation, so you need not remember this. So at the end of the day, just remember that A can be written as half of A plus A transpose and half of A minus A transpose. So already I have proved that A plus A transpose is symmetric and A minus A transpose is skew symmetric. Are we sure of this? If yes, then definitely this is my P and this is my Q. So I did what? I have managed to represent the given matrix A as sum of a symmetric matrix and a skew symmetric matrix. So when I am writing the final answer, how I am writing this? So this matrix can be written as half into 2, 5, 5, 8 plus half of 0, minus 1, 1, 0. So this is my answer. This is my final answer. So you have to leave your answer like this. So because this is the question, you are representing a given matrix as sum of a symmetric and a skew symmetric matrix. So this is the matrix given and this is your symmetric matrix and this is your skew symmetric matrix. So this is all for this class, and now I need to solve the problems as I have promised. So let me just find where the problems are kept. Okay, I have kept it somewhere. Yes. So now I haven't sent the problems yet for exercise 3.3, which I will definitely send. So before we do so, let me just solve few typical problems, and you can solve the rest of the problems all by yourself. um, and obviously, if you are having a textbook, that is your prescribed textbook, whichever you are asked to buy, please ensure once this is done, you go through the exercises from there and solve the problems from there itself. Now I am running out of pages. Okay, no, I am not running out of pages. Fine. So exercise 3.3 question number 1. Exercise 3.3 question number 1 subpart 1. So you are given this matrix A, 5, half, 1, and you are just asked to find the transpose of it. So if I am transposing it, it is a column matrix. So when a column matrix is transposed, so it is in a form of column. So the idea of transpose is just changing rows into columns and column into rows. So if it is just a column, then this column becomes a row. So therefore the transpose is 5, half, 1. I think this is pretty clear. Now, next question. Okay. Next question. It is given A transpose is given 3, 4, minus 1, 2, 0, 1. B is given minus 1, 2, 1, 1, 2, 3. And then I have to verify this. A plus B whole dash is equals to A dash plus B dash. So now let me first find A dash is given. So what is A? Now obviously rows become column and column becomes row. So this is 3, 4, minus 1, 2, 0, 1. Fine. And also let me find what is B dash. B dash is minus 1, 1, 2, 2, 1, 3. So let me keep all the things in front of my head. So now let me start with LHS and RHS. We have to do them separately as it is a verification problem. Never ever start a verification problem by putting the equal to in between. You are not supposed to do that. You are verifying. So that means what? You start from one side, you solve one side, you start the second side, solve the second side, and then show that both the answers are equal. So this is LHS, this is RHS. So LHS is A plus B whole dash. So this is A is this. So let me just write it. 3 minus 1, 0, 4, 2, 1 plus B is minus 1, 2, 1, 1, 2, 3, and taking the whole transpose of this. So that means 3 plus minus 1 is your 2, minus 1 plus 2 is 1, 0 plus 1 is 1, 4 plus 1 is 5, 2 plus 2 is 4, 1 plus 3 is 4. So transpose of that. So it becomes 2, 1, 1, 5, 4, 4. So this is your answer on the left hand side. Now let us do it on the right hand side. So A dash is 3, 4. So I am trying to do A dash plus B dash. So this is minus 1, 2, 0, 1 plus minus 1, 1, 2, 2, 1, 3. So 3 minus 1 is 2, 4 plus 1 is 5, minus 1 plus 2 is 1, 2 plus 2 is 4, 1 plus 1 is 0, and this is 4. So they are equal. So therefore it is verified. Next. Okay. The next one is, once again, I have to verify something. So what is, if you want to see, just check it once again. I hope you will be able to understand. Now let us move to question number 5. Question number 5 is, you are supposed to verify that AB whole transpose is equals to B transpose A transpose. What is A given? A given is 1 minus 4 3. B given is minus 1 2 1. Okay. So first let me find what is A transpose. A transpose is nothing but the same thing in row 1 minus 4 3, and B transpose is same thing in column minus 1 2 1. Fine. Now again the same thing that we do, LHS RHS. So in the LHS part we have AB whole transpose. So first let me find out what is AB. AB is, let me just write it from here itself. I'm not going to copy it down. Again the same thing, rows getting multiplied with the columns. So only one element in the row, only one element in the column. So this is, again, understand, this is 3 cross 1, that is 3 rows 1 column. This is 1 row 3 column. So your final matrix is going to be a 3 by 3 matrix. So let me first multiply. So 1 into minus 1, this is minus 1. 1 into 2, this is 2. 1 into 1, this is 1. Minus 4 into minus 1, 4. Minus 4 into 2, minus 8. Minus 4 into 1, minus 4. 3 into minus 1, minus 3. This is 6. This is 3. And I have to take transpose of this. So if I take transpose of this, this ends up becoming minus 1, 2, 1, 4, minus 8, 4, minus 3, 6, 3. So this is your final answer for left hand side. Now let us do the right hand side. So this is B dash A dash. So B dash A dash. So B dash A dash, let me just write it first. So B dash is minus 1, 2, 1, and A dash is 1, minus 4, 3. So the same thing once again. Minus 1 into 1, that is minus 1. Minus 1 into minus 4, that is 4. Minus 1 into 3, that is minus 3. 2 into 1, that is 2. 2 into minus 4, minus 8. 2 into 3, that is 6. 1 into 1 is 1. This is minus 4. This is 3. So we can see the answers are equal. So once it has come equal, that means it is verified. So verified. Fine. Now the last one, number 10. So A is given this 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. So this is the matrix given, and you are asked to express this as the sum of symmetric and skew symmetric matrices. So now first let me find out what is A transpose. Now A transpose is just the same thing written, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. So exactly the same matrix. Actually it is, there is nothing, this in itself is a symmetric matrix. So your P matrix, that is half of A plus A transpose, that is exactly, A transpose is same as A, so it becomes A exactly. So this is nothing but 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. And Q, that is half of A minus A transpose. Now A and A transpose are same, so this is actually the null matrix. So finally, what is A? A is actually equals to, this is the matrix 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3 plus the null matrix. So here this A matrix in itself is acting as the symmetric matrix because it is given symmetric right from the beginning, and as there is, the matrix in itself is symmetric, so there is no antisymmetric part of it. So the antisymmetric part is played by the null matrix. So this was a very special example, that's why I have solved separately. Rest of the problems, they are just common problems, so do check on these problems and try solving them on your own. If doubts are there, once again I'll clarify it later. So thank you.